Matrices and transformations. Using matrices, we can change the shape of any figure we desire using preset matrices, knowing exactly how its shape will change and where it will end up on the plane. In this video, I will show you how matrices work in reflections. Before continuing, you should remember how to multiply matrices. Pay attention to the matrix multiplication below. It will be used a lot in transformation matrices. When we multiply a 2 by 1 column vector by a 2 by 2 matrix, results in a 2 by 1 column vector. For example, matrix A and matrix B are column vector B. Let's multiply them. When we perform this multiplication, we get a new column vector. Matrix multiplication, as we did above, can be used to transform points in a plane. Transformations can be represented by 2 by 2 matrices, and other pairs coordinates can be represented by 2 by 1 matrices, column vectors. Let's see how it works. Take the position vector P and matrix A. Then multiply this column vector by a matrix and look what happens to the point P. We get a new column vector that represents a new point in the coordinate system. We can see that the A matrix has changed the point P to the point P1. The point P1 is called image point of point P. A matrix changed the position of point P. The A matrix is called of transformation matrix. To transform a point with coordinates x and y by a transformation matrix, multiply the two matrices together. In general, a transformation is written as new coordinates equals matrix transformation times original coordinates. The transformation matrix has an effect on each point of the plane. To find out which transformation a matrix represents, it's useful to use the following steps. Reflections across the y-axis. Select the points 1, 0 and 0, 1. Look at the diagram. Find the image of these points under the given transformation you want to. The y-coordinate remains unchanged, but the x-coordinate changes sign. Write down the position vectors of these images. The position vector of the image of the first point becomes the first column, and the position vector of the image of the second point is the second column of the required matrix. This transformation matrix creates a reflection in the y-axis. When multiplying by this matrix, the y-coordinate remains unchanged, but the x-coordinate changes sign. This matrix represents reflection across y-axis. Let's see how it works. Example. Draw the image of the triangle ABC and the image of the point P under reflection across the y-axis. The point P is represented by a column vector. We must express the shape of triangle as a matrix. Each point becomes a column in this matrix. Let's take the triangle ABC and express it as a matrix. The vertices of the triangle can be put into one 2x3 matrix. Pay attention. Now we take the transformation matrix and left multiply it by column vector. The result is a matrix of coordinates of the resulting shape after the transformation is applied. In this case, the point P1. The image point is then drawn on the diagram. Let's make the same with triangle ABC. We take the transformation matrix and left multiply it by the shape matrix of triangle ABC. The result is a matrix of coordinates of the resulting shape after the transformation is applied. The image points are then drawn on the diagram and we get the image of the triangle ABC. To obtain the transformation matrix of the reflections across the x-axis, we follow the same way. Select the points 1, 0 and 0, 1. Find the image of these points under the given transformation you want to. Write down the position vectors of these images. The position vector of the image of the first point becomes the first column, and the position vector of the image of the second point is the second column of the required matrix. This transformation matrix creates a reflection in the x-axis. When multiplying by this matrix, the x-coordinate remains unchanged, but the y-coordinate changes sign. Let's see how it works. Example, draw the image of the triangle ABC under reflection across the x-axis. Take the triangle ABC and express it as a matrix. We take the transformation matrix and left multiply it by the shape matrix of triangle ABC. The result is a matrix of coordinates of the resulting shape after the transformation is applied. The image points are then drawn on the diagram and we get the image of triangle ABC. From the diagram, it can be seen that the triangle has been reflected in the x-axis.